Okay, so day 5, the last day of this unit, puts everything together. So we are to graph this rational function. And so first of all, to find any horizontal asymptotes, we take a look at the first term of the numerator and denominator. And since it's same, the degrees are the same, we just take the ratio of the coefficients, 3 over 1, and that's y equals 3, and there's our horizontal asymptote. Again, it only determines n behavior, so as we go to the left, we're getting closer to 3. As we go to the right, we're getting closer to 3. The denominator can be factored. Nothing reduces out. So when this equals 0, I get my vertical asymptotes when x equals -2 and when x equals 2. Here and here. To get the x-intercept, the function has to equal 0, and for a fraction, that's just the top, or the numerator, and that's 3x squared, so clearly x equals 0 when y equals 0. As it turns out, our x-intercept is the same as our y-intercept. To double check, we take our function, replace x by 0, and we get 0 over -4, which is of course 0, and so our x-intercept and y-intercept are the same. We test our critical values, which is found by breaking up our number line by the vertical asymptotes and the x-intercepts. So at -2, 0, and 2, those are the boundaries for our critical regions. So to the left of -2, I just picked -3. You can pick anything you want to. And I look at the expression, and if I square anything, it's positive. So the numerator is always going to be positive for all of these, so I can ignore that after now. And if I place -3 for x, this will be negative, this will be negative, and a negative times a negative is a positive. So the denominator is positive, and a positive over positive is positive. So to the left of -2, that region is positive. Between -2 and 0, I chose -1 as my test point. I plug -1 into the first factor of the denominator. +2, that's positive. -2 stays negative. A positive times a negative is a negative. And a positive over a negative is a negative. So then between -2 and 0, we have a negative region. Between 0 and 2, I just picked 1 as a test point. And so if I plug in 1 in the denominator, I get a positive, and 1 minus 2 is a negative, so that's still negative. And so that's negative. And so between 0 and 2, that's still negative. And last but not least, to the right of 2, the last vertical asymptote, I plugged in 3, and everything's positive, so it's positive, the last region. So if you think about it, I have these asymptotes. I could draw it wrong this way. This includes another x-intercept that doesn't exist, and over here it's negative. So going along the asymptotes that way isn't going to work. But if I go this way, then it's positive, and it goes along the asymptotes. Between -2 and 0, it's negative. So it's going to go down from this x-intercept. It's going to go through the x-intercept and go down. And then to the right of 0, 2, it's also going to go down because it's negative as well, and go along the asymptotes. Then to the right, it's positive. Along the asymptotes, it's got to just go this way. Because if I did this, it would be negative part of the way, and there'd be another x-intercept that I never talked about. So for example, 2 and 3, what I did is I numbered the directions. 1 would be the end behavior horizontal asymptotes, 2 vertical asymptotes and holes, 3 intercepts, and 4 testing regions. So then, for the horizontal asymptote, I see that this is bottom heavy, so right away I know that the horizontal asymptote is y equals 0. I factor what I can, and the x plus 2, x minus 2 factors in the denominator. Nothing reduces out, so those two, if I set them equal to 0, give me my vertical asymptotes at x equals negative 2 and at x equals 2. To find the x-intercept, I set the function equal to 0, and to do that, I just set the numerator equal to 0, and I get 0. So 0, 0 is the x-intercept, and as we just saw in the previous example, if that's the x-intercept, it's also the y-intercept because it hits both the x and y axis. Same thing we did in the last one. We test regions. Negative 3 is to the left of negative 2. Negative 1 is between 0 and negative 2. 1 is between 0 and 2. And let's say 3 is between 2 and to the right of infinity. I plug in negative 3 here. It's going to be negative. I plug in negative 3 here. It's going to be negative. And I plug in negative 3 here. It's negative. So a negative times a negative is a positive, and a negative over a positive is a negative. So to the left of negative 2, that region is negative. I plug in negative 1 into the expression. Do you see that I'll get a negative over a negative, which is a positive? So there's the next region. If I plug in 1, do you see that the numerator will now be positive? The denominator will still be negative, and that's a negative. So to the right of 0, it'll be a negative region. And you see if I plug in 3, which represents the region to the right of 2, everything is going to be positive, and so that region is positive. So for me to draw something that goes towards the asymptotes and is negative, it starts here, goes down, and this is just a rough sketch. If I wanted more definitive shape, I'd plot more points, but that's not the issue for this section. Here, where it's positive, it's going to go from the x-intercept or y-intercept and then up positive along that asymptote. Here it's negative, so it's going to go down to the right between 0 and 2. To the right of 2, it's positive, so it's going to go towards the asymptotes and stay above the x-axis. That seems to do the trick. This one looks similar. But it's same. The degrees are the same, so the horizontal asymptote is the ratio of the coefficients 2 over 1 or 2, y equals 2. There's the horizontal asymptote. I factor and nothing reduces out, so I set the denominator equal to 0, and I get the two vertical asymptotes, x equals negative 2 and x equals 2. Set the top of the fraction equal to 0, and 0, 0 again is the y-intercept, and x-intercept in this case. Testing regions, just like before, I would plug in negative 3, negative 1, 1, and 3 to represent the regions between the vertical asymptotes and the x-intercepts. Notice I don't worry about the y-intercept. Even in this case, it's the same thing as the x-intercept. And so I'll let you do the plugging in of those numbers. Did you come out with this region being positive, this negative, and this positive? Hopefully now you can see that this is positive and goes towards the asymptotes. This is negative from that intercept. This is negative from that intercept along those two asymptotes. And then positive to the right of 2 going towards those two asymptotes as boundaries.